since we now know the special angles and the ratios associated with them, we can simplify trig expressions without using our calculator. So the first thing I want us to do is draw out our special triangles so that we can use them in the next few examples. If you would like, you can pause the video here, try to draw them on your own, and then check with my answers. The first triangle we have is the isosceles triangle with the 45 degrees. The equal sides are both 1 and the hypotenuse is √2. Then we have the equilateral triangle that has been split in two so that we have the 60 and the 30 degrees. The equal sides are 2, the base is split in half, so its side length is 1, and the height is √3. And finally, we have the imaginary 0-90 triangle, where the base angle is 90 and the top is 0, and our side lengths are 1, 1, and 0. And now, let's go ahead and simplify some expressions. Now, what you will see in these first three examples is that none of the angles are actually 60, 30, 45, 0, or 90. Instead, they are angles in quadrants 2, 3, or 4, but the reference angle is 45. So we do have to use our knowledge of the cast rule here. So if I want to evaluate sine 120 degrees, the first thing I'm going to do is draw a little grid, and 120 degrees is in quadrant number 2, which already tells me in quadrant 2, sine is positive. So we have to use our cast rule connection here. Now, you might also want to label your 0 and your 180, maybe your 90, 270, and where 360 is, just for the reference of where different angles will be. And now, my alpha, my reference angle, is always with the x-axis because that's how our triangle is created. So our reference angle is here, and our actual 120 degrees is here, which means our alpha is 180 subtract 120, which is 60 degrees. So now we know that really we just want to evaluate sine 60, and in quadrant 2, sine is positive, so sine 120 will also be positive. So now I just go up to my 60-degree triangle here, and I know sine is opposite over hypotenuse, so √3 over 2, and it will be the positive version. So sine 120 equals √3 over 2, and that's it. Now, let's go on to the next one. We have cos of 225. So again, I'm going to draw a little grid here, remind myself of the cast rule. And 225 is in quadrant 3, so our alpha will be right over here, but the 225 is this entire angle. So our alpha is going to be 225 subtract 180, which is 45 degrees. And we are in quadrant 3 where only tan is positive, but we have cos. So we have to remember that our ratio will be the negative version. Okay, so now let's go to our 45-degree special triangle, and we want to figure out cos of 45. So adjacent over hypotenuse, so that would be 1 over √2. And we have to remember it's the negative version. So cos 225 is negative 1 over √2. And we know that is not proper form. We have to rationalize the denominator, so multiply top and bottom by √2, so that we have negative √2 over the whole number 2. Now for the next one, I put a reciprocal ratio. So I have cotangent of 330. So first thing we want to do is figure out what tan of 330 is equal to, and then we'll take the reciprocal of that to get cotangent. So again, I'm going to start with my little Cartesian grid, and 330 degrees will be in quadrant 4. And that is the C quadrant, which means in quadrant 4, tan is negative. So we have to keep that in mind. And now 330 is this giant angle, and our alpha is this small angle. So alpha is going to be 360 subtract 330, which is 30 degrees. Now we can figure out what tan of 30 degrees is, and we have to keep in mind that it will be the negative version. So looking at our equilateral triangle and using 30 as our reference angle, tan is opposite over adjacent. So 1 over root 3. And it's going to be the negative version. So negative 1 over root 3. And I'm not going to worry about rationalizing the denominator because when I take the reciprocal, that radical will go up into the numerator. So cotangent of 330 is negative root 3 over 1, or just negative root 3. And now for our final example, I have a longer expression. So I have cos 45 plus cosecant 150 minus 2 times tan 60 times sine 240. So I have 4 different ratios I have to figure out and put it together. So I'm going to go piece by piece, and I'm going to start with cos 45. And for cos 45, I don't have to worry about any other quadrant. I can go up to my 45-degree triangle. Cos is adjacent over hypotenuse, so 1 over root 2. And it's going to be positive because it is in quadrant number 1. And I'm just going to highlight this because I will use it later on. The next ratio I want is cosecant of 150. And before I find cosecant of 150, I'm going to find the primary trig ratio first. So I'm going to find sine of 150 first, and then I will take its reciprocal. Now for sine 150, I know it's in quadrant 2, which means it is the positive ratio. And if this entire angle is 150, and my reference angle is in here, my alpha is going to be 180 minus 150, which is 30. So I just need to figure out what sine 30 is, and it's going to stay that positive version. So I'm going to go up to my 30 triangle. Here we are. Opposite is 1, hypotenuse is 2. So sine 150 is positive 1/2. And our reciprocal, so the cosecant of 150, is just going to be positive 2. And I'm going to highlight that ratio because I will use it later on. And I just realized from above I forgot to rationalize 1 over root 2. So I'm going to multiply top and bottom by root 2, and that will give me root 2 over 2. And that's the ratio I will use later on. And now I'm going to move on to tan 60. Tan 60, I can just go up to my triangle. Here's the 60, and I want opposite over adjacent, which is root 3. So tan 60 is just the square root of 3. And the final ratio we need is sine of 240. So I'm going to draw my little grid. 240 is in quadrant 3, and in quadrant 3, only tan is positive, which means sine will be negative. Our 240 is this big angle here, so my alpha is inside the triangle created with the x-axis. So to find alpha, I'm going to do 240 minus 180, which is 60. So I want to figure out sine of 60, and it will be the negative version. So I'm going to go up to my 60 triangle. Sine is opposite root 3 over hypotenuse, which is 2. So negative root 3 over 2, because it is in quadrant 3. Now that I have all 4 of the ratios I need, I can go put them into my expression. So we have cos 45, which we rationalized and got root 2 over 2, plus cosecant of 150, which was just 2, minus the coefficient of 2. Now I need tan 60, which is just root 3, and then I need sine of 240, which is negative root 3 over 2. And now I just have to clean this up. And what I'm going to do, I'm going to make sure all of these have a common denominator so I can create one fraction for my final answer. So I have root 2 over 2, and this constant of 2, I'm going to write it as 2 over 1, and if I want that common denominator of 2, I'm going to multiply my numerator and denominator by 2 to get 4 over 2. And the rest of these, it's a multiplication of those three numbers, so I'm going to multiply my numerators, multiply my denominators. And I do notice I have a negative here and a negative here, so it will turn into addition. And now for my numerator, I'm doing 2 times root 3 times root 3. Root 3 times root 3 is root 9, which is just a whole number of 3, and that will get multiplied by 2 to get 6. And for my denominator, I'm doing 1 times 2, which is 2. And now we can just add our numerators. So I have root 2, and then 4 plus 6 is 10, and that will be all over 2. So you can write your answer like this. And the reason I wanted to get a common denominator to turn it into one fraction was just in case I had some radicals I needed to collect and simplify. So at this point, you can write your final answer like this, or you can also write it as root 2 over 2 plus 5. Both would work. So that's how you simplify your trig expressions. You want to figure out what reference angle you are using. You want to figure out if you're positive or negative using your cast rule, and then you go to your special triangles and use your reference angle to find the ratios.